Right, so as I said, you're welcome to this class, and today we're gonna be looking at the concept of sets. Of course, we are moving or we're explaining this in the direction of economics because of the structure of the course. So, what is a set? I'm sure you've heard of the word before or have seen the word set. So, a set, of course, we're gonna define this mathematically. We're just saying that it's a collection of what? Of distinct objects. It's a well-defined collection of what? Distinct objects or what? Or elements. So it is well-defined, meaning that it has no ambiguity to it. You are going to know if it's a collection of bananas, then it's a collection of what? Bananas. If it's a collection of vehicles, it's a collection of what? Vehicles. If it's a collection of shoes, it's a collection of what? Of shoes. So it has to be what? Well defined. And so we are saying that which allows us, so this collection of objects or elements allows us to have a relevant economic what? Economic analysis. So these elements can be anything. So as we've said, so in terms of economics, so from economic variables, so they can be like prices or quantities, to collections of choices or constraints faced by what? Economic agents. So those things that such as consumers, firms, or what? Or governments. So those are the economic agents. So now, as you said that in terms of economics, they can be anything. They can even be prices or quantities. They can even be choices that a firm is going to what? Is going to make. That can be what? Can be defined as a set. So, but then we know that in simple matters, what we are saying, let's put this now in terms of math. We're just saying that the order does not matter. When we say distinct objects, or in terms of a set, the order in which those elements may be listed does not matter. So the set containing 2, 3, 5, and 7, like this, in this order, is equal to the set that is going to contain 7, 5, 3, and what? And 2. So the order doesn't really matter. But of course, you'd usually prefer to write them from either ascending order as either in ascending order or in what? In descending order. But then it does not really matter. It does not change the what? The set. The set still becomes what? The same. And of course, when we're listing out a set, we do not what? We do not repeat things. So for example, if you have a collection of vehicles and then you are listing that list, you're listing that set, and then in your set you have maybe um, you have a BMW in there and you have a Ford. Even if there are two Fords, they are just going to list it what once to say you have a Ford in there. So when it comes to set, we don't repeat what? We don't repeat the elements. Okay, so our notation now, let's talk about the notation. So of course, we will say if we will write that when we want to say that a certain object or an element is a member of the set, then we say, okay, X is a member of what? X is a member of the set A. So when we write this means that X is what is contained in the set A. Then if we want to say it's not a member, then we say X is not a member like this of what? Of A. So this here is how we are going to denote what? Denote sets. So sets in the course will be denoted by what? Capital letters. So use capital letters to denote what? To denote the set. Like here, capital letter A, even there you see capital letter A. That's how we're going to denote what? Denote our sets. And of course now, just not talking about numbers and all, if we look at real life examples of what? Of sets, you have, for example, um, a set of firms producing what? Producing phones, a set of firms that are producing phones. So that set, what would be contained in that set? Okay, so the purpose of the live class is for you to participate. So we said an example of a real life situation, that is, we're saying a set of what? A set of firms that are producing what? Producing phones. So this set of firms is producing phones. So now what could be in this set? What would be those firms that are producing phones? Anyone to list any that they may know? Okay, so there's no one to do that. So the set of firms that are producing phones. Of course, if you have a phone, you probably know that one of the leading phones is what is Apple. So we know there's Apple, there's there's um, there's what? There's Samsung, there's Huawei, there is Techno, there is so many other phones, of course. I think that we can list that are what that are so many other firms that we can list that are producing phones. And then we can have for example, another set is maybe set of what of of companies that are selling out food products. So you have so many of those. For example, you have ShopRite there, you have Pick and Pay, they sell out food products there. You have Choppies and all those other ones that you can list. So that there is going to be what to be a set like that. So a set is just a collection of well-defined objects. All right, so next we're just going to be looking at a few of the terminologies here and there. First of all is the two ways in which we describe sets. So the main ways, of course, there's two main ways in which we describe sets. And the first one is set builder what? Set builder notation. So set builder notation, you see something like this. For example, right, the set O is just equal to, so if I write it in the term where I say the set of OX such that X is a member of integers. So X is a member of the integers, and um, we are saying that is in between. So and X is in between 0, 0 and what? And 8. And is given by what? By this formula that is X is equal to what? To 2k. Like this. Okay, so this here is what could be what? What could be our set in what? Set builder notation. So this here is set builder notation. When we write a set like this, where we say we use the language, of course, where we say the first here, the set of OX, this line here just means such that, then I say X is a member of, so I'm defining where the set is, it's an integer, and then it's in between 0 and what? And 8, including 0 and 8, because there's less than or equal to here, and then it's given by the formula what? X is equal to 2k. So this here is what we use by set builder notation. Then another way in which we describe sets is the common way which we know is by listing out. So by listing, which we call it's called tabular tabular or roster form. It's called tabular or what? Or roster form, where you just list out the elements that are in that set. So for example, this set here, what will be the elements that are in what? In this set. What are the elements that are in this set? Remember, X has been given, said X is equal to what? To 2, what? To 2k. What are the elements that are what? That are in this set? And X is an what? Is an integer. We've been told that X is what? Is an integer. So what are the elements in this set? Anyone? Okay, so the elements in this set, so you see that X is being given by what? 2k, where k is also what? Is also an integer. So this means by the 2 there, it means that X is going to be what? Is an even number. So X is an even number. And then we've been told from our this set bit notation that X is in between 0 and what? And 8. So meaning starting from 0, 0 is going to be there. If I put 0 where k is, we're just going to have 0. And then let me put 1. So if I put 1 here where k is, so I say where there's k, I put 1, and then I just get that this will give me 2. So the next value is going to be what? To be 2, because 2 here, the value of x is going to be 2, and 2 is in between 0 and what? And 8, so I get 2. I put 2 here, and then I just multiply. So x equal to 2 multiplied by 2, this gives me what? 4. Meaning the next value there is 4. Then I put 3, I'll just get what? 6. Then when I put what? When I put 4, 2 by 4, this gives me what? 8. So 8 there. And 8 is the what? Is our last value where we are restricted. So we've listed out this set. And this here is what we call what? This is what we call the tabular form, or the what? Or the roster form, where we just what? List out our what? Our elements. Okay, so this is very keen to note. Okay, so what is the next concept that we want to look at? So the next concept that we're going to look at is some special type of sets. So some special type of sets. The first one which we're going to look at is the empty set. The empty set. So what is this empty set? So the empty set is denoted by, okay, so I can say a 0 and then you draw a line there. So that there is what? The empty set. And the empty set, by definition, is just a set that has no elements. It's empty. There's nothing in there. It has no elements. So that's an empty set. And then another special type of set that we are going to define is a singleton set. What is a singleton set? Anyone? What is a singleton set? What is your understanding of the term singleton? What's a singleton set? All right, so a singleton set is just a set that contains exactly one element. That it contains exactly one element. For example, let's say the set containing the letter A. So this is a singleton set because it contains only one element. Then I can have a set containing maybe the number 1, like that. So on and so forth. So if it only has one element, then it's called a singleton set. Then something that is very important for you to note here on what we said on the empty set. So there's a difference. So this here, okay, let me write. I should have written this as brackets and I just said empty set like that. Okay, so this here is what is inside is the empty set. So there's a difference between the empty set. This here is the empty set, and this here, if I write like this, I write these brackets. So these curly brackets here are what we are going to be using in listing out our sets. So if I write the curly bracket like this and I write the empty set inside the empty set and these are not equal. So this here on the left side is the empty set. While on the right side, this is the set containing the empty set. So this set containing the empty set has an element, which is the empty set. But the empty set itself is what is empty. So the empty set is not equal to the set containing the empty set. So that is something that you must take note of. All right. Is there any questions so far? Okay, so there's no question. The next concept that we're going to look at here is subsets. So what is a subset? So look at subsets. So a subset, so we say that a set, for example, a set A, the set A is said to be a subset of Of B, is said to be a subset of Of B, if everything that is in A is also is also in B. So we denote this as A is a subset of Of B. So A is said to be a subset of B if every element that is in that is in A is contained also in in B. Then we say that A is the is subset of B. So writing that, we're just saying that this here just implies for all. So this symbol here, an upside down A, just means for every or for all. So for all X, this would imply, or this would mean that X is is a member of A, implies that X is also is also in B. That's what a subset is. If it's contained in A and it's also contained in B, then we say that A is the the subset of Of B. Okay, another term that we must note is proper Proper subset. Proper subset. So what is a proper subset? So if A is contained in B, like this, if A is contained in B, this means that A is contained in B, and B is not is not equal. I mean A is not equal to to B. So this here, we use this notation here when we mean it's a proper subset. which means that A is contained in B, meaning it's true this way that A is contained in B, but A is not what? Is not equal to what? To B. They are not equal. Then we say that that's a proper what? A proper subset. So there are facts that we must know about what? About these subsets. For example, is the first one is that the empty set is a subset of what? Of every set. The empty set is a subset of what? Every set. It's contained in what? In every set. And then every what? Every set is a subset of what? Of itself. Every set is a subset of what? Of itself. So for example, let's have the set A to be listed as 1, 2, 3. So 1, 2, and what? And 3. So this here, in this set, the empty set is what is contained in there, since we've said that the empty set is a subset of every set. And then this set here, set A is a what? Is a subset of what? Of itself, set A. Set A is contained in what? In set A. So, and since the elements are what? Are the same, that's why we just say A is equal to what? Is equal to A. So every subset, every set is a subset of what? Of itself. That's something that you must what? We must take note of. All right. The other key terms that we must now know. Okay, so the other key terms that we must know is cardinality. So cardinality. So what is cardinality? So cardinality, which we denote as modulus there and say S, like this. So here, this cardinality is just the number of what? Of elements in that set. The number of what? Elements in that set. Okay, so for example, what is the cardinality of the empty set? What is the cardinality of the empty set? Yeah, just unmute your mic and speak. Okay, so the cardinality of the empty set, since the empty set has no elements, meaning that the number of elements in the empty set is what? Is 0, since it does not what? Have any elements. So the cardinality is what? Is 0. And then, for example, if we had the set of what? Set of prime numbers, set of prime numbers, set of prime numbers, prime numbers. This set here. So the set of prime numbers, what are prime numbers? Prime numbers are numbers that are divisible by 1 and what? And the number itself only. So how many prime numbers do we have that are what? That are in between? So the cardinality, for example, cardinality of prime numbers that are, let's say, less than what? Less than 100. Meaning we're asking for how many prime numbers are what? Are there that are less than what? Than 900. So you just count those what? Those prime numbers, and that's the cardinality. And we know that we just have 25 what? 25 primes that are less than what? That are less than 100. Okay, so that is the concept of what? Of cardinality. The next term that we're going to look at, or that we're going to define, is the power set. So power set. So the power set, which we denote P of S like this, is just, of course, this being any set. S is just standing for any set. So the power set is the set of all subsets. This is a set containing all subsets. So now, an example, we can say if we have the set A, and the set A which is given or contains the elements A and what? And B. So the power set of A, is just the set that will contain all subsets of what? All the subsets of A. And that set is going to be, so first of all, you know that since we said that the empty set is a subset of every set, meaning that the first set is going to be what? The empty set, since it's going to be what? Contained there automatically. And then what is the next set that will be here? So the next subset is the set containing what? A only. Then the next subset is the set that is going to contain what? B only. And then the next subset is the set itself. So A, comma what, comma B there. So this here is what is the power set of what? Of the set A. So the power set, as we've said, is just a set of all subsets. So this A contains all the subset of what? Of A. All sets that can what? Can be contained in what? In A. Okay. And then one particular rule that we must we must note in order to find the cardinality of what? Of the power set. So in order to find the cardinality of the power set, it's defined by, so the cardinality of the power set is defined by P, that is S like that, equal to 2n. S is equal to 2n. And then n is obtained by what? The cardinality of what? Of the set. So in our case here, if we were to get the what? The power, if, so the cardinality of this set here, the cardinality of A, so cardinality of A, how many elements are in A? We only have two, 1 and 2. So 2 there. So now, what is going to be the cardinality of what? Of the power set of A? So the cardinality of the power set of A is going to be equal to, so this 2 is the what? Is the n. So I'll say 2 to the power what? The n is 2. And this here just gives us what? 4. And as you can see, we have 1, 2, 3, 4 subsets that are contained there. So that's how you get what? That's how you get to find the cardinality of what? Of the power set. All right, so these are the main or the basic concepts that we must understand about what? About sets. So now, from here, what we're going to do next is we're just going to basically look at the set operations briefly. I know maybe you've come across them and maybe you know them, but in brief explanation, the operations, the set operations, we have the first, we'll say union. So union, which is denoted as, if you have two sets, A, union, so this symbol in between, union, B, this just means, this means that what? The elements, so we're looking at elements that are in A or in what? In B. Either they're in A or they're in B or in what? In both. That's what the union what? The union takes. So writing it mathematically, I'll just say this here is a set of what? OX. The set of OX such that X is a member of A or X is a member of what? Is a member of B or what? Or both. Just write it there. And then intersection A intersect. So the symbol, you just like that, looks like an N, intersect B. So this here is showing us elements that are common in both A and B. Elements, what elements are the same in what? In A and B. What elements are contained in both what? The sets. That's what this means. And then you have now the set difference. So set difference A, and you have a what? A difference sign here or subtraction sign. B like that. So this is a set difference. So this here is telling us elements that are in A, but they are not in what? But they are not in B. Elements that are in A, but they are not in what? They are not in B. That is the what? The set difference. So in set beta notation, I would say X such that X is a member of A and X is not in what? Is not a member of what? Of B. So this here is what the set difference means. And then you have the complement of the set. So you have A, the C there stands for complement of the set. So the complement of the set is everything that is not what? Every element that is not contained in A, but sits in the universal set. It's not in A, but it is in the what? Universal set. That is the complement of the set. And then the last here, we're just saying that disjoint sets, when you have two sets that are not what? Overlapping, they're not overlapping. So usually our sets, you have them to overlap like this. But then if they don't overlap like this, then it means that what? They are disjoint, meaning you have a set there and a set there like that. Okay. So now, speaking of these overlapping sets, we can now even talk about or introduce the fact of what? Of Venn diagrams. So in sets, we'll use the Venn diagram what? A lot. So this is a way in which we can what? Represent sets, where the outside here, where you can say U, or sometimes they write E, just stands for what? Universal set. And inside here, you have sets that will be contained, and they overlap. So overlapping like this, overlapping like this. So they overlap if they have what? Common elements. And they'll be named different. Maybe this is set A, that is set B, and that is set what? Set C. So these are the sets that you might what? You might have like that. So you put the elements that are contained in A there, in B, in C, here that are common in both A and B, they are common in what? In C and what? In C and B. And then you have those that are common in what? In all of them, that are common in all the in all the three what? In all the three sets. So these are the set what? The set operations. So these are the set what? Operations in what? In brief. Okay, now we move on to what we were wanting to reach, or the point that we're wanting to reach. Where do we apply all this knowledge? Where do we apply all these type of definitions of sets that we're looking at here? So we're going to apply them now here, where we are talking of. So here we have this question. So we look at questions now. So the first question is saying consider two sets. So it's saying consider two sets where we have set A, and set A is a set representing consumers who prefer product what? Product A. So the set A is just a set that is denoting consumers who prefer what? Product A. Okay, product X, I mean, product X. So let me write it here. I'll say that this here is just, so I'll write here that A is equal to, so A is equal to so A is equal to consumers who, consumers who what? Who prefer product what? Who prefer product? Prefer product X. Then B, okay, I'll just say product what? Product. I mean, B, we say product what? Product Y. So here, B is a set of set representing consumers who prefer product what? Product Y. Now, they're telling us determine and interpret the following in the context of what? Of market segmentation. So they're saying we should what? Interpret the following. That is A union B, A intersect B. It's the difference of A and B. Then here A intersect what? B complement. Then we should interpret all this in terms of what? Market segmentation. So first of all, we must understand what is market segmentation. So market segmentation is the strategic practice of dividing a broad target market into smaller, more manageable what? Groups. So we're dividing into smaller, more what? More manageable groups of what? Of consumers who share what? Who share similar characteristics, needs, or what? Or behaviors. So in short, we are going to be breaking down this into smaller what? Smaller chunks, or into smaller what? Into smaller groups based on the what? On the sets that have been what? Have been given here. We're going to divide that into what? Into smaller groupings. So how do we do this? How are we going to find this? So the first one that we are being asked there is, the first one is A union B. So what is A union B? So A union B. How do we interpret A union B? A union B. How do we interpret this A union B? So this A union B, as we say that for what the union does is picks elements either in set A or in B or in what? Or in both the sets. So now, how do we what? Define? Because it's saying define and what? Interpret the following in the context of what? Market segmentation. So to define our A union B. So our A union B is just consumers, because here we're looking at consumers. Consumers who what? Who prefer product X or prefer what? Product B, or they prefer what? Both the products X and what? And B. That's what our union is B is going to what? To mean. So this here is going to mean consumers. This means consumers who prefer what? Who prefer product what? Product X, or product what? Product Y, or what? Or both the products. So that is what the union is what is interpreting, or what the union what means here in this context. Okay, the next we have what? The intersection. So what is this intersection going to mean? Or what does this intersection mean? So we have that our intersection is going to mean, since intersection looks at the elements that are both in that are in both sets. So A intersect B is just going to mean consumers who prefer what? Both the products, what? X and what? And B. Okay, so now we forgot one part here, we're rushing. So this part here says interpret. So what do we make sense of the union here which we found? So the interpretation of this is just the total what? The total potential market. So this here is just the total potential what? Potential market for the products that we have, either the product X or what? Or the product what? Y. So that's the total potential what market. The union is what is going to what? To give you. Okay, now let's look at the intersection. So the intersection A intersect B. So what is A intersect B going to be? So A intersect B, we say that these are the consumers that what? Consumers that like both what? Both the products. Those that prefer what? Both products. Or they like what? Both the what? The products. So these both like X and what? And Y. Then what do we interpret of this? So this here, we just make an interpretation. We're saying these are the what? Consumers with overlapping what? Preferences in your what? In your market. So these here, they like what? They like both. So their potential what? Potential targets for what? For building a what? A cross what? Promotion between the two, because they like both the what? The products. And then we have the next one, that is A, set difference of A and B. So what is this set difference of A and B? So the set difference of A and B looks at what? Consumers who what? Who prefer. Since we said the set difference here, we are saying that elements that are in A, but they are not in what? They are not in B. So now what will this mean? So now this here just means consumers who what? Consumers who prefer product X, but they don't prefer what? Product Y. So they only prefer what? These consumers who prefer product X what only, and not what? Not product Y. This is what it means in our what? In our context. So then how do we interpret this? So this here, the interpretation is, it just makes a niche or a segment of what? Of loyal what? Loyal consumers to what? To the product X. So this just tells us those that are what? That are loyal consumers to the what? To the product what? The product X. So because they only like the product X and they don't want what? They don't like the product what? The product Y. So that's how we can interpret it. And then here, this A intersect B complement. A intersect B complement is the same as what? Is the same as A, the set difference of A and what? And B. Because you can write this, the other way of writing this, say set difference of A intersect B, is writing A intersect and then the complement goes to the what? To the B. So meaning this here will just have the what? The same interpretation, which we've already looked at, that is saying that they are what? They are, which is saying that they like what? They like only one product. Okay, I don't know if there are any questions where we have reached. Are there any questions? Okay, so if there are no questions, we end here for today's class, and I'm gonna see you in the next one. So remember to subscribe and share, and then for more videos and for more access to full lessons, even past papers, even tutorial sheets, you can visit what? Our website at discretelearningwhat.com. So how you do that is you open your browser. When you open your browser, whatever you're using, whether you're using Chrome, you're using Edge, just search here Discrete Learning. So discretelearning.com, and then it comes up there. And then when it comes up here, if you don't have an account, you can sign up for an account. When you visit here, if you don't have an account, just sign up for an account, and then you start learning. So you start learning here, it will take you for you to to make an account if you don't have one, and then you look at all these other courses that we offer. So we offer so many courses. So it depends with the course that you want. So but then for this course, you find them here, statistics and probability. For economics, you find it there. And then you have math for economics. So you find the materials, the past papers, and then the tutorial sheets will be uploaded. So when the choice sheet comes out, we solve it, and then we upload it, and then you access the solutions here. And also solutions to the past papers, you find them you find them here. All right, so that is it for today, and I'll see you in the next one.